This is a demonstration of installing and configuring the Cloud Resources Data Collector, which is delivered with IBM Cloud App Management. You can configure the Cloud Resource Data Collector for monitoring the applications in your Kubernetes environment, including any Nginx or Redis workloads. Let's start by opening a terminal window and changing directory to where we downloaded the agent installation image for Linux systems from Passport Advantage. We did this earlier when we installed the IBM Cloud App Management agent. Change directory into the folder that was created when we extracted the package. List the contents. Observe there's two files. One is the agent's media, the other is the Cloud Resources Data Collector. Note the name of this file. Let's list the path to this file so we can use it when we copy this file over. Change directories into Downloads ICAM and make a new folder called Data Collector. This will be our working directory to install the Data Collector. Let's copy the Data Collector install media into our current working folder. List the contents of this working folder. You can see we have the Data Collector install media in it. Let's extract this file with a tar ZXVF. List the contents of the folder again, and you can see we have a new directory called Cloud Resources DC 2018.4.0. Let's change directory into that. Let's list the contents of the folder, and you can observe we've got some compressed files, a README, and a Helm main.yaml file. Let's return to IBM Cloud Private and log into IBM Cloud App Management. So let's minimize the terminal window, open up a Firefox browser, and provide an admin user ID and credentials. Select Menu, Dashboard, make sure everything's up, and let's do Menu, Workloads, Brokered Services, and click Launch. Click Get Started. Click Cloud Resources. You can observe we have no cloud resources defined yet because we haven't installed the Data Collector. Click Get Started. Click Download File. This downloads our config pack for the Data Collector. Click Save File and OK. And let's copy this file that we just downloaded into our working directory. Which again was Downloads ICAM Data Collector. Minimize this display and return to IBM Cloud Private. Click on our user ID in the upper right and click Configure Client. Copy the commands into your clipboard and return to the terminal window. Paste the commands in to configure your client. Issue the command helm init client only to initialize a Helm environment. Next, log into Docker. Copy the config pack into our Cloud Resources DC 2018.4 folder. List the contents of the folder. Observe at this point we have a Helm main YAML file, we have a README file, and we have 4 compressed files. Let's find the IP address that our Nginx environment is using. So do a kubectl get pods, all namespaces, -o wide, and grep on Nginx. You can observe the address in our case is 10.1.119.216. Let's repeat the command, except this time let's do a grep on Redis to find the IP addresses we need for the Redis servers. Observe there are 3 Redis servers in my environment, and we'll need to give all those 3 IP addresses into our Helm deploy command. So the command we use to deploy our Helm chart is Ansible playbook. Give it the helm main.yaml file, and the extra vars we supply the cluster name, the release name. You make up a release name of your choice, has to be unique. So I want IBM Cloud App Management DC. Give it your namespace. And then we're going to go with the Nginx URL that we discovered above, that 10.1.119.216. It's HTTP, and the port by default is 18080. You put the Nginx status string after it. Spy your Docker registry and let TLS enable equal true, and then Redis URLs equals, and we're going to go with those 3 Redis servers we supplied. This time instead of HTTP it's TCP. The port by default is 6379. So we repeat that 3 times, 1 for each of the Redis servers. Double check your work, make sure your IP addresses all match up, and then let the Ansible command run. It'll run in a few minutes. You can see the Helm chart is unpacked, the Docker images are loaded, the images are tagged, and after a few minutes you get a message which says how many of the tasks were okay, how many of them were failed. In our case, everything was okay, so we can proceed. So let's validate the deployment was successful with the kubectl get deployment command. Give it your release name of your Helm chart, followed by -k8 monitor, and specify your namespace. You can see the deployment has been up for 1 minute. Let's retrieve the command and change the deployment to be our release name followed by app management telegraph. Again, specify your namespace. You can see this deployment's been up for 1 minute as well. So our deployments were successful. Let's return to IBM Cloud App Management. Select your Firefox browser and return to the Cloud App Management tab. Click IBM Cloud App Management Advanced. Click Cloud Resources. Observe now we've got a lot of data that's been collected on Kubernetes. So we have data on our Redis servers and our Nginx server. Click View Resources under the Kubernetes cluster and click your cluster name under the resource column. Scroll down and observe the related resources topology. Here you see a display of all the nodes in your Kubernetes cluster. As you hover your mouse over the different nodes, details about that particular node are displayed on the right. Select Cloud Resources. Next, let's confirm our data collector is pulling in data for our Redis servers. Click View Resources under Redis Server. Select one of the resources in the resource column. Scroll down and observe the data that's collected. Click Cloud Resources. Click View Resources under the Nginx server. Click the resource in the resource column. You can observe here data collected on our Nginx server. Next, let's review our incidents that are coming in for our cloud resources. Click IBM Cloud App Management Advanced, and then All Incidents on the Incidents tab. Click Settings. Scroll down and select Priority 4 under Show Priority. Verify some incidents have arrived from your data collector. This concludes this demonstration of installing the Cloud Resources Data Collector inside of IBM Cloud App Management.